Yeah, started now. Okay. So this is, you can see that this is the main method, right? What we are doing here is, so okay, I wanted to start with the demo, right? So this, so you, what you can see is when I started the service, what it does, it's kind of, it's logging that, okay, what are the number of documents? So these are the 3 documents it's referring to, which are there in the doc folder. And then how many number of segments from chunker, right? So what it's also doing is, let's say it's taking this document, and then it's dividing this document itself into chunks, and then so that's what it's trying to log here, that there are 193 chunks in total in all these documents. And then it's generating a vector for each of those chunks, right? So okay, we'll go into detail of each of these, but just to demo, right? So I'll now, let's say, let me so one of the document you can see is of a bird, right? So let me ask a question that, for example, what is bird, right? And let's see whether it's able to give response. Yeah, so it's saying BERT stands for bidirectional encoder representation from transformers. And adding to the document, it is a new language representation model designed to pre-train whatever, right? So it's basically, it's able to answer the question that you can see in, let's say, in let's say sufficient kind of words, right? Maybe this much line of information is enough for a user. So it's able to answer in certain way. And how it is basing this information, right? So whether it's pulling this information from the LLM, or so LLM, I'm using Gemini. So not the full Gemini model, but I have taken this one, which is a trimmed down version of the Gemini, the Gemini Lite model. So I've taken that. So in the background, it's talking to that. So the LLM is not hosted on my laptop. This LLM is hosted on the on maybe Google server itself. It's just trying to talk to this over HTTP, right? And it's a smaller model. So so let's say what I'm trying to say is that if I don't train this with this document, right, this bird paper document which I have given here, it will not be able to answer this question, right? But since I have trained it, then it's able to answer this question. So what to see this live, right? What we can do is I can take any paper, right? So I think we have a lot of paper, so I'll just take one of the paper and train it with that. Design papers. So let's take any paper. Cassandra.
Kunal, does it mean then whatever you are training the LLM with, that is the only scope of its knowledge base?
So sir, so this is a no. So source of knowledge base is also what is there in LLM also, right?
Right.
I'm
So
not
like
trying to
when you say
deny.
BERT, so BERT, it may be something it already has in it, right? Already. Don't.
It may already know about it also, right? But ये
Right.
छोटा model है, मतलब it's like
Hmm.
maybe few billion parameters.
Right.
I'm not sure if I've
तो
written
But
that.
कुणाल एक
mainly towards the customized data that we are feeding it to, it will mainly give the response
Ah,
accordingly, right?
yes, it
हाँ
will
कुणाल
give.
एक मतलब इसका एक टेस्ट ले सकते हैं ना हम लोग पहले मतलब बिफोर ट्रेनिंग एक क्वेश्चन पूछ जो स्पेसिफिक टू ये हो और आफ्टर ट्रेनिंग एक
वही मैं
क्वेश्चन
कर रहा हूँ, वही कर रहा हूँ मैं. So
अच्छा अच्छा
I'm just what I'm doing is I'll just find some document, right? Uh, yeah. Sorry, this document I downloaded, right, Cassandra?
Cassandra, it might have been already trained this model, right? Something
Like
which is not very general purpose.
for example, what is Cassandra? So it's saying I don't have enough information in provided context, right?
Oh.
Now I can take that paper. I think I lost the link, so I'll just open again. Oh no, it's not working.
Use Control P once.
Okay. So I'll just try to save it in that context itself. And this is document drawings. Okay, so I'm saving this in the LLM, right? Okay. I'll just check where this is hosted. Yeah, this is inside this link. Yeah, docs is here, right? So we'll try to put it here.
लास्ट वाला है ना लक्ष्मण
So ये है क्या?
हाँ
And this one, yeah. This is yeah. So now I put it here. I think in Telegram, so we will see the paper is here. So this is still not ingested because I'll have to restart the server. So I'll just try to now restart it. Yeah. Now you can see there are 4 documents, and then the chunk size also became 193 to became 237, right? Now let's ask the question: what is Cassandra? So then now it's able to answer that Cassandra is a distributed storage system managing a wide large of this and then. So this you can see that it's of course, if we try to see this sentence might be there in that paper, or it's trying to build some understanding based on that, right? I'll just try to quickly see if we can find. Maybe whole sentence I will not be able to find. It's not doing a key based match. It's not like a lexical search is doing. So this is a distributed system for managing a very, I think only first few lines also you can see that this is something which is picked from the paper itself, right? So this we can go on, right? We can add different kind of documents, and then maybe we can add multiple documents related to Cassandra itself, and then we can maybe refine this, right? And we can, let's say, ask something about data model of Cassandra. Let me see if I'm not sure whether it will answer or not. What is the data model of Cassandra? Okay, saying I don't have enough information. So maybe it's not able to do all those things that intelligently, right? And then it might go back to how I'm basically chunking, putting that information and all. So we can do some optimization on those also to see if we can enhance these qualities of this answer itself, right? But at least what you can see is that it's able to now take the information from the documents which we provide, and this is the truly RAG in the work, right? So what we are doing is, so this is like in your company, if you have, let's say, a lot of your product requirement documents, your engineering documentations, right? What you can do is you can build an app like this and put up a UI on top of it, and then all the knowledge inside your team, inside your company, can be accessed using a chat interface by grounding it in one of the RAG application, right? Okay, so I think demo is fine. Now let's go through how this is being done, right? So so this is the RAG app. Inside the RAG app, we will see what it's doing is it's just taking all the documents which are put in this document folder. It's pulling that out, and then it's seeing it should be a PDF, and then it's just trying to load all of those documents into this documents, right? And then it's returning this documents in memory. The document it is returning. Why I'm doing like this is because I want to convert that into embedding. So first I'm reading all the text files that I have into this documents variable, and this is getting returned from here. Now what main app does is it initializes the chunker. Now this chunker we can see, you can just go inside this chunker class, you can see what all it supports. It supports gets chunk. So given a list of documents, it will return the chunks of that, right? And why is chunking important? Chunking is important is because all the any embedding model that we'll use, there would be some restriction on the size of that embedding model, right? So you cannot basically give us an entire document, maybe 10-page, 20-page document, and then it cannot convert a vector from that, right? So it will not work out basically because there would be some limitations on it. Typically embedding models, if you see, they will support 512 tokens or 28092 tokens, right? So this is the general range. Maybe there could be higher also, but I'm just trying to give an idea that the token limitations on embedding models. I'm not talking about LLM token models. Those are very different, right? I'm talking about text embedding models, and there is certain token limitation on that. So that is the reason you need to chunk your data, right? So you cannot feed your entire document. You need to split your document into smaller chunks, and those chunks then will get fed into the vector database. So this is the chunking step. In the chunking step, again, the documents which we read in memory, that we are giving it to it, and then it's basically going over that recursively, and then it's trying to create small segments, right? And this is the number of segments.
कुछ मतलब कोई एल्गोरिथम यूज किया है क्या चंक करने के लिए, या फिर जस्ट टेक्स्ट को स्प्लिट किया है? मतलब बेसिकली आई मीन जस्ट टेक्स्ट लिया, उसको स्प्लिट किया है, कोई मतलब क्लस्टर सिमेंटिक या फिक्स साइज विंडो या ऐसे कुछ एल्गोरिथम यूज किया, स्लाइडिंग विंडो या फिर फिक्स साइज, ऐसा कुछ एल्गोरिथम?
सो इसमें बस एक सिंपल सी स्ट्रेटजी है जितिन. सो कोई ऐसे आउट ऑफ द बॉक्स कुछ यूज नहीं किया, एंड आई थिंक इट्स बेटर to use some of those, but if for this app I have not used it. So what this app does, it just breaks it based on the character size, right? So I'll just say 500 characters, and it will take a chunk of 500 characters and the next 500 and next 500, like that. It will split the document into this, right? But typically, जैसे तुम कह रहे हो, right? It would be more intelligent to, let's say, divide it into a paragraph, right? And then take अगर paragraph कोई pause हो रहा है तो you just take that as a chunk, right? So that way, what you're trying to do is you're trying to represent the knowledge in a very structured way, right? Because एक paragraph typically एक kind of knowledge को represent कर रहा होगा, right? So that way you might get a better output from the questions that you will ask at this stage, right? Some of the questions that you're asking, it might give you a better response if you have used better strategy for chunking. So अभी बस ये कर रहा है, it's just trying to split based on the character length, and then it's trying to just add some overlap, right? ताकि context जो है वो मतलब vectors के next vectors में lost ना हो. So it will just try to overlap. So let's say the first one is of 500 characters. It will after 400 it will take the 100 from that in the next line also.
Okay.
Next
वो है एक strategy है वो.
That is only that is doing, nothing else, right? But I mean maybe you can talk about that, right? More, what are the more intelligent ways to generate that chunk so that the retrieval retrieval quality is enhanced, right? Okay. So this is how what it has done, right? Now we'll go back, right? So this basically divided the document into smaller segments or chunks, and then it is returning back to again main, right?
Yeah, I think one more strategy people follow for creating a chunk is that they use LLM to generate a chunk first, and then they
Ah,
do
right.
the embedding. Like instead of simply doing based on a words or doing 20% overlap or paragraph, they first use
Mm.
one LLM, saying that okay, this is the document, create a chunk with the meaningful information, and then you create a vector embedding of each chunk.
Yeah, so I think what you are saying is the LLM may support a very large token size, right? Which your embedding model might not support. So now
Yes.
you can maybe give the entire document, right? मतलब लेकिन I don't think वो 10 or 20 pages के document ले पाएगा, right?
Not in entire document, but let's say by page wise also, you can say that, okay,
Ah.
from this page, create a 400 words paragraph.
Hmm.
So instead of you saying that, okay, you are going by paragraph, you read the complete page and then create a 400 words summary or whatever the report you want to create a chunk, then put it.
Yeah, so that way I think maybe the LLM is already summarizing it, right? So and that you are vectorizing that summary, right? So that way
Correct.
maybe the output will be of a different quality in that case, right?
Hmm.
Yeah. So this we done. Now you can see that there is an embedding store getting initialized, right? And this is again an important part. So each of the pieces which I'm basically telling here, by the way, all I have done in a single app, right? But all of that could be different services hosted completely differently on integrated through gRPC or REST, right? So that it's important that we understand each of these things in that sense, right? That each of these could be a completely different service, different modules, and different components, right, in this app. So now here I'm using an embedding model, in-memory embedding store, right? And this is, I think, this is from Hugging Face, or yeah, I think this is from Hugging Face. This in-memory embedding model. So in-memory embedding store, right? So what this store is doing is that the vector database part. So the vector database, I'm not using, let's say, Milvus or Vespa or Pinecone on these kind of data stores. This is an in-memory store itself, which I'm using, right? So so that I think you can understand it, right? So it's just creating the embedding and storing that in the RAM itself, right? That's what is important. But again, let's say you want to change this and then make it like a production ready app, then you can convert it into uh, basically use any of these data stores like Quadrant or Milvus or Vespa, right? And just you have to change this layer out of it. So what that will help is, what I'm doing is that I'm putting the document here, and when I'm starting the app, at that point of time itself, it's chunking it and then creating the vector index and then storing it in memory, right? Now you can have a completely separate ingestion pipeline, right? Which you can say this is a batch pipeline. So every once in a day or once in an hour, it can just look at that directory and look at what are the new documents which are added, convert, do the chunking, and then finally store that into the quadrant and vector database. So this needs so that that would be like a production ready app, and then it can as and when new documents are available, it can enlarge it, right? Because you can understand this will not scale beyond a point, right? If you, let's say, put 100 documents here, this app will take a lot of time to start. In fact, in memory may, of course, you will not be able to support beyond a certain size of the embedding, right? So this is the only for demo that I'm using this embedding store. Now embedding model. So embedding model also, I think, let's go to, I can display from here that what is the embedding model I'm using. Yeah, so embedding model I'm using is this LangChain 4 embedding all mini LLM 16 v2, right? So this is an embedding model supported by this, and then I think we can look at the more constructs on what kind of what kind of dimension. So you can see that this supports a 384 dimension dense vector. This is an embedding model, and this is based on Hugging Face sentence transformer, all mini LLM6 v2, right? So this, Jitin, you were asking, right? What is the this is using, right? Yeah. So these details, I think you can look back on what is the kind of embedding model which is getting used. And by the way, we can again plug in any kind of different embedding models, and then the more, so you can see that this is just 384 dimension, right, which is very small, and that is the reason it was not able to answer the question on the data model for Cassandra, right? But if we take a larger embedding model, right, maybe next dimension could be, it would be I think 768, right, or maybe 1000 plus size, right? So when you have a larger embedding model which you can use for production use cases, then it can of course answer more complex questions.
Maybe file type is also the reason. What I think is, I'm trying to recall one of the discussion Varun, was making. He said that PDFs are not that good when he was trying to upload it to Notebook LM, and he said that try to use markup files which are like better suited for LLMs to understand, or embedding model to understand. Just a thought.
So Brijesh, the way I understand it, right? So now all these PDF, what you are doing is this step which I showed, right? The step where you are generating segments, text segments from the document, right? So you have extracted the text part. Now that text you have represented in a TXT file or docs file or PDF file. After this layer, it does not matter, right?
That's correct. But I mean, my question is that part only, that whether it is able to extract PDFs as good as it is able to extract the other markup file or text file.
So that is this piece of code itself, right? This you can argue whether this piece of code is effective or not, right? Because here what I'm doing is I'm just dividing that document into 100 characters, 200 characters, first 100, right? So that you can argue, but एक बार वो ये step हो गया, after that, I mean, vector and retrieval layer is not bothered about what was your source of information, right? So maybe I can just put up a crawler here, right, which goes to the web and then crawls some web pages and finally takes the text out of it, right? And then I can use for chunking, right?
Okay.
Okay. So this part, embedding model, we have seen. Now the vector database part. So again, a vector database is nothing but a wrapper over the embedding store itself, in-memory embedding store, which we saw here, which is just writing in RAM. So this is just taking all these parameters and then effectively it will write in RAM itself, right? Now what I've called is vector data just ingest, right? And then I've taken segments. So this ingest, what it is doing is it's taking the document and then convert it to the segments or chunks individual, and then it will go call ingest, right? Now we'll go into ingest. What ingest is doing is whatever embedding model that we have defined, right? It just gave the documents to it. So this is just nothing but just an array of documents, right? Array of the segments that we created out of all these documents, right? So how many segments were there? There were around 217, right? I think, yeah, 237 segments. So maybe you can say that small 237 paragraphs it has created out of all these 4 documents. And then it just called the embedding model that, okay, these are the paragraphs. So let's say some of the paragraph is like this, right? So it took this document and then said, can you give me an embedding for this or a vector representation for this, right? And then it did for all the entire 237, right? And this is the response that we got. So inside this, I think we can just see what's doing is, so let's say, this is again a library from, I think, Hugging Face or LangChain ka library hai. So this implementation, you can see, maybe you can say, ye wala implementation lete hain. So this is just taken the text model and then inside it's trying to, I mean, parse all these. I've not gone into this thing, but actually what this text embedding model that we specified, right, in the POM. Yeah, so this is using this model and then giving us the vector. So text to vector conversion jo ho raha hai, that is happening at this layer, right? So this is important to understand in that sense. Yeah, so we have seen that now the entire document has been ingested into this. Now after that is just the one more layer is the LLM part. Now LLM I'm using Gemini, smaller version of Gemini again. So this also I can I will just show. Yeah. So this is again a LangChain Google AI Gemini. This library I'm using to talk to this LLM, and you can see my environment file where I've given the keys for. Yeah, this one. Yeah, you can see I've given the keys here for Gemini API, right? This key I've generated. I went to the Google AI Studio and then I've generated this key. This is sample and free key, and I have put it here. There are also Hugging Face, OpenAI, and Grok keys, which I've used for different purposes, not for this. I think Hugging Face is something that I've used for the embedding generation. So this is the key, and then this is the key which I'm using for LLM to talk to this Gemini LLM, right? So now now comes the part of the read part, right? Where you have a prompt and then you are asking a question. Now this part, what it's doing is again it's just trying to. So this you can of course replace by a chat app tomorrow. This is just a console-based discussion, right, with the LLM. So this is what it's doing. Nothing is whatever context which I gave here, right? Like what is the data model for Cassandra I gave. So it took this input, and then this input it just converted it to a vector again, right? And now you understand why it's converted to vector, because it has to go and query the vector database. So inside the vector database, what it will do is it will do a nearest neighbor search, right? So this thing, like what is the data model for Cassandra, or any question that we ask, what is Cassandra, it will convert to a vector. And for converting to the vector, it will again use the same embedding model that we talked about here in the POM, which is the Hugging Face text embedding model. So that embedding model it will use, and we'll see. Let's see how it's calling that.
ये कुणाल, ये जो एम्बेडिंग मॉडल का जो कन्वर्शन है ये थर्ड पार्टी से हो रहा है ना, जहाँ तक मुझे समझ में आया है। मतलब जो एपीआई है, आई थिंक जैसे फॉर एग्जांपल हम गूगल कोलैब यूज करते हैं तो हम लोग उसी के जीपीयू से हम लोग कन्वर्ट करते हैं, मतलब विदाउट यूजिंग एनी थर्ड पार्टी। यहाँ पे आई थिंक थर्ड पार्टी से कर रहा है।
करेक्ट, ये हगिंग फेस से कर रहा है।
हाँ, ओके,
हगिंग फेस को यूज करके ये टेक्स्ट एम्बेडिंग कन्वर्ट कर रहा है।
बिकॉज ये सिस्टम आई थिंक बहुत स्लो हो जाएगा अगर हम लोग यहाँ पे लोकली करेंगे तो इसको, है ना? मतलब वैसे मतलब अगर गूगल कोलैब
लोकली होस्ट होता है यार, ये दिस यू कैन होस्ट लोकली आल्सो, दिस इज नॉट दैट
नहीं, बट आई थिंक ये बहुत स्लो हो जाएगा ना, क्योंकि हम लोग अपने लैपटॉप में जीपीयू वगैरह यूज नहीं कर सकते ना। जो गूगल कोलैब है उसमें अगर हम करेंगे तो
I think CPU पे भी चल जाना चाहिए। लेटेंसी आई थिंक you will get maybe a higher latency, right? But ये CPU पे भी चल जाएगा।
अच्छा, ओके। नहीं, मैंने ट्राई किया था।
Kunal, can you show this content retriever how this retrieves Hugging?
Yeah.
It is converting it to embeddings, right? The question.
So this is the question which I have asked, and this is present in this question, right? And then it's going inside this, right? So you can see that it's calling retrieve, right? Now what it is doing inside is that यहाँ पे query embedding model को call कर रहा है, and then embed call कर रहा है. Wherever it's calling embed, I think it's generating the embedding itself, right? So now it's going here and embed का यहाँ पे देख लेते हैं. It took the response, then expected as embedding, but got this. So it's able to get the embeddings from here. Again, this is the same piece of code which we call during the content imaging generation. This is inside the library again, not going there. Right? Yeah, so it basically converted the user question also to an embedding, right? And then this embedding, it's So यहाँ पे what it is doing is it converted it to the embedding, and then it queried the vector database, and then it brought the contents, right? And now this content is basically a text content. So what happened is, let's say when we chunk this document, right? Let's say Cassandra ka document, then for each of the chunks, it converted to an embedding, but along with the chunks, it also stored the payload as payload, the entire actual real raw data also, right? Raw text data be it stored. So whenever we are doing a lookup from the user query, it's trying to do a let's say cosine similarity, nearest neighbor lookup, or HNSW index, depending on what database you are using, right? And then it will pull the nearest vector, but actually it will respond here with the content and not the vector database, because अब आपको you have to feed this to the LLM, so you want the actual text data here, right? So that text data now you are getting here, which you will see here. Then now it's trying to create a prompt, right? And this is a custom prompt, custom English prompt, and we can change anything. The prompt which you have given is, you are a helpful assistant, answer the questions using only the context below. If the context does not contain enough information, say I don't have enough information in the provided context. And this is what you got, right? Whenever, let's say, this question didn't match any vector, underlying vector, then it always said, I don't have enough confidence. So in that case, this contents would not have retrieved anything for, let's say, what is the data model for Cassandra. So in this context, this might be empty. And in that case, it's saying I don't have this because I have asked it in the prompt that to answer that way itself, right? So if the context does not contain enough information, say I don't have enough information about the product context, and then I'm asking it to code the source also. I mean, which part of document, which chunk you have used to answer that question, right? So that also is there, and then you put that.
So this way you have restricted the LLM to answer generic questions. Like when you asked what is Cassandra without having the Cassandra document, you have asked it to not to respond with that, even if LLM might have that information.
Yeah. So I've just asked it to stay grounded instead of hallucinating one part of it. But let's try this, right? And then we can so add. So if you answer the question, this part let me remove, right? And this part also. And let's see how it behaves, right? Okay, this one maybe I can leave for now. Let me stop and again start the server. Start this main method. Yeah. Now I'll ask this question: what is data model of Cassandra? Data model Cassandra is described as being highly structured. According to the document, the value is an object which is highly structured. So I think now it's able to answer the question. I'm not sure whether it took it from that document itself or the LLM is able to answer this, right? Because that prompt I've removed, that if you're not getting any answer, don't answer, right? If you're not getting any similar results from the vector database, don't answer. So it's able to answer. So thoda sa loose ho gaya abhi, right? Now it can maybe take this little more liberty to answer those questions. But this will have, I mean, consequences both way also. Sometimes you will see it hallucinating and maybe randomly answering. Maybe ye wala bhi answer you can understand, right? It's not actually the kind of answer we would want, right?
अभी इसका टेम्परेचर सेट कर देंगे 0.
हाँ, right. So this is yeah. ठीक है. So now this is the part. I think most of the things I would have covered in this, right? हाँ, ये वाला छोड़ देते हैं. Yeah. So we covered all the aspects to it. Just trying to if I have to reiterate, there is a chunker which basically segments the document that we have given. Then there is a content retriever which basically pulls the document based on the user's question from the vector database. Then there is an embedding model. Embedding model is basically it works on both at the read time and the write time. At the write time, it basically takes those chunks and then convert into vectors and then puts into the vector database. and at the read time, it will also take the user's query and convert it to an embedding, and then use that for retrieving the vectors and the associated payload, right? This is very important part, by the way, that both these should be same embedding model, right? अगर आप writing के लिए कोई और embedding model use कर रहे हो, read के time कोई और embedding use कर रहे हो, तो you can understand this will not work, right? And then this is just to load the API keys, right? LLM we have seen, so I'm using Gemini lighter Gemini, and this is not hosted on my local, but this is hosted there. And then I think these things we have covered. So I hope this makes sense. I think I can take any questions on this before I move to the next part. Yeah.
It was really good.
Okay, any
I
questions?
think this context is what matters across different LLMs. हम उसमें देखते हैं ना कि as this version progresses, this context size is getting increased by everywhere. I mean, अगर हम GPT-2, GPT-3 की बात करें, it was a very short context. But अभी हम काफी large हो गया अभी context new models में. You can put a lot of data there.
This is nice, Kunal. Means you have like taken the main part of our RAG application, like what and all has to be there, and we can like enhance in each layer, as you said, like embedding model, LLM, and as we do that, this will be a production ready RAG application. Nice.
Yes. Yeah. So just small tweaks wherever you can do, right? So this thing these are my config, like, right? So what I've done here is there are two things which I'm putting here. One is the max size in CADs, right? So ये जो जितिन को मैं बता रहा था. So this is, I have divided the document into this size, and then this is the overlap I have allowed between the consecutive chunks, right? So 200.
कुणाल, वैसे तूने जो मॉडल लिया था ना, वो उसका जो साइज था, आई थिंक कुछ कितना था, 300 कुछ था ना शायद से, मतलब
कौन सा मॉडल?
जो अभी जो तूने दिखाया था उसमें जो
this one.
हाँ, तो फिर 1000 का अगर हम लोग लेंगे तो वो कॉन्टेक्स्ट को एक्सीड नहीं कर जाएगा, मतलब काफी ज्यादा
नहीं, वही तो दो चीजें है ना यहाँ पे. एक है कि जो मैं डॉक्यूमेंट को स्प्लिट कर रहा हूँ 1000 साइज में. डॉक्यूमेंट के एक पैराग्राफ को जो मैं पिक कर रहा हूँ ना, दैट इज ऑफ 1000 कैरेक्टर्स, राइट?
वही मैं कह रहा हूँ, बट उसमें 1000 में मतलब आई थिंक अगर हम लोग उसको,
अच्छा, so for this model I would say I can tell you what is the constraint on input text, right? Let me ask this for the same model, right? This is saying 256 word pieces tokens. This is saying 256 tokens में डाल सकता हूँ इसमें, right? Again, not character, this is tokens. So just understand these two things, right? कोई भी embedding model है तो उसका दो है, एक input है, एक output है, right? So output is a vector, right? And output was of this 384 dimension, right? जो output आएगा वो 384 साइज का आएगा, बट उसको input कितना दे सकते हो, कितने साइज का text दे सकते हो उसको, right? So that it generates that output. That is 256 word piece for this LangChain, this particular model, right? अब this one
इनपुट में हम लोग इतने को हम लोग चंक कर रहे हैं ना, मतलब इतने साइज के डेटा को तो हम चंक कर रहे हैं ना, या फिर इससे कम रखेंगे तभी वो मतलब कॉन्टेक्स्ट रिटेन कर पाएगा. अगर हम लोग
ज्यादा रखोगे तो no point, because it will truncate, right? It will not, maybe it will not throw an error, right? But it will just truncate. It will not take, because उसकी कैपेसिटी नहीं है, तो वो 256 वर्ड्स ही लेगा यहाँ पे, 256 टोकन्स ही लेगा, राइट? अब जैसे यहाँ पे ना मैं ये तो जिस सिंपल
कैरेक्टर एक्चुअली, हाँ मैंने चेक किया 1024 के ऊपर जा रहा है, हाँ तो हो जाएगा उसमें वो.
हाँ, तो इसमें कुछ भी 250 के आसपास या कुछ आएगा, राइट? एवरेज अगर हम कोड लेंगे तो एक टोकन के. बट ये आई थिंक दिस वन व्हाट आई वांटेड, बट ये तो समझ में, ये तो क्लियर हो गया ना सबको, राइट? कि जो भी एम्बेडिंग मॉडल है उसमें भी दो साइड्स हैं, राइट? एंड उस दोनों पे सर्टेन रिस्ट्रिक्शन होगा. कोई भी एनी एम्बेडिंग मॉडल दैट वी आर यूजिंग, देयर वुड बी रिस्ट्रिक्शन ऑन व्हाट इज तो बेस्ट क्या होता है, राइट? आई कुड फीड द एंटायर डॉक्यूमेंट, राइट? दैट वुड बी द बेस्ट थिंग, राइट? बट वो पॉसिबल नहीं है बिकॉज ऑफ दिस रिस्ट्रिक्शन that it will just only take a certain size of the token. So that is the reason I need to put some checks like this. Best होता कि मैं word count token ही count कर लेता and 256 token पे मैं truncate कर देता, right? That is the best way to maybe input in this case. 1 second, somebody. Hello.
हाँ आ रही है बच
त्यागी से ज्वाइन कर रहे हैं ना, ड्रॉप हो गए? ठीक है, ओके. So yeah, this is important to understand both this part, and then this one is the overlap, which is कि पहले और दूसरे जो consecutive chunks में उसमें मैंने 200 का overlap दिया है. Right now, let's say this if we decrease it to, let's say मैं 100 कर देता हूँ या 50 कर देता हूँ, right? And this if I do it 500, now you will see कि जो मेरा output होगा ना, जो questions which I will ask, that will be even worse. मतलब if I ask a question like, can you tell me what is bird? Maybe उस केस में उतने सही से वो आंसर नहीं कर पाएगा, right? So this you can just tweak. I try to play around. पहले मैंने इसको small size रखा था. Then I have just to increase the quality, I make it 1000 and 200. So this also we can play around. And of course we can just then go and change the embedding model itself and LLM जो underlying use कर रहे हैं. Vector database we can change it to maybe instead of in memory the actual real vector database. So these are some of the enhancements we can do to enhance it. And this I think something like these, I think all the organizations will do now, because all their documentations they will try to convert it to a knowledge base for everybody to just quickly understand it and then go through that, right? This is also as an application in your let's say debugging के लिए कुछ tool बनाना चाहते हैं, right? या फिर हम लोग on call के लिए कुछ support करना चाहते हैं, right? So this you can use in your on call. So let's say all your product documents, all your confluence, right? Everything you can put it into an app like this, right? And then so I think एक चीज I don't know notice किया है कि नहीं आप लोगों ने, right? So now all the LLMs also support that chain of thoughts reasoning, right? So there are models which have evolved recently, which are I think last year I think is evolved where there are reasoning models which have come, right? जैसे O series के models हैं इसके reasoning models from OpenAI. This one, right? O1 mini. So these are the reasoning models. So these are not just they are not just outputting the next tokens, right? Which typically your decoder of the transformer does it. What these are doing is these are trying to reason in steps. So they can use the question and they can understand the context, and then they can create a series of steps. Now, since they can create the series of steps, they can create a plan, and then because of this plan, they can this can be then used by an agent to basically execute an MCP based architecture, right? It can ask questions to the underlying database. It can, and then it can do some debugging on behalf of us, and then answer the questions which an on-call issue and all these things, right? So यहाँ पे, I mean this would be another architecture, right? What we can say is that we will use an embedding based model, we will use an LLM, and we can use a reasoning based model also. Using all the three, and then using RAG and MCP, we can completely automate, right? Or let's say to a certain extent, we can automate the on-call ticket wala part. Any user will just give a question, and then the reasoning model will create the number of the steps from that, and then this step will be executed using the MCP by an agent, and then the output again would be structured by a LLM back to the user, right? So you can solve the on-call ticket issue by using this architecture, right? Okay. I'll just take just एक और इसमें नया architecture है which I would just like to mention about. Yeah. Yes. So now, now what has happened? There is one more architecture which has evolved, which is called as graph rag. And graph rag primarily, I think, is this screen visible? Is this image visible?
हाँ
मैं थोड़ा सा zoom कर लेता हूँ इसको, right? So what graph rag does it? So generally, I think what we have seen is कि architecture इस तरह का था, right? There's a user who is asking the question. That question we are taking and we will convert it to embedding, and then that embedding we will put into a vector database, and that we will pass on to an LLM, and then it will answer the question. But abhi, what has happened is, because of the graph, in graph rag, what happens is you can take the question, and this particular question, then you can put it to a graph database, right? And graph database, what it does, it is able to, let's say, store relationship between different kinds of the entities, and because of that relationship there is a reasoning also which can happen here, right? So for example, if I talk about what example should I take, right? If I talk about, let's say, simple, let's say, employee search use case, right? Or let's say e-commerce, if I talk about e-commerce use case, if I talk about, so there is a, let's say, user who is looking for a certain t-shirt, right? Now when so this question, let's say, if you put up you have created a graph database out of all the products that are there, and then who is the user who is trying to interact with that product, and based on that you have created, let's say, a relationship diagram, right? Let's say certain user came, and then they are interacted with, let's say, 100 different products, right? Now there is another user who is again interacting with 100 different users, and some of them he has added to cart, and some of them he has purchased. Now to this user, if there, let's say, there is some commonality between these two products, then maybe you can suggest those products which the first user has added to cart or purchased to this user also, right? So some kind of a recommendation system that you can do because based of this graph, right? Now let's say when the user is trying to search for something or ask a question, what you can do is you can put this question to this knowledge graph, and this knowledge graph can, based on the relationship that it is having internally, which it can take that relationship, and that relationship can be given to the LLM, and now the LLM can reason better because it knows that how these outputs are related to each other, right? अभी हम वेक्टर के केस में क्या कर रहे थे कि we just took the generated the embedding, and that embedding we have put into the this, right? And then when we are asking, it's just trying to do a similarity match, right? थोड़ा सा meaning वगैरह match किया, and then it brought in that the text part, and then that text was used to answer back the question. But here you can see this is little more structured in the sense that it's able to store the relationship between those entities, right? And then it's answering the questions in that sense. This you will see that this will always perform better, the graph rag. And there is a pattern also to combine all of these three, right? Which this diagram is showing, that you take up the user's question, then you put it to the graph search, you also put it to the vector search also, and then in vector search you do both the search. You also do a keyword based lookup, which is like our traditional searches that we are doing, right? Lexical searches. So you basically take the keywords, then you put it to your data stores, and whatever documents that you pull in, those documents or those segments, and then the vector ka segment, and then the graph segment. You give all of these as a context to the LLM, and then LLM can generate the response much better, because now it's grounded in all these three to answer the question, right? I hope this pattern is clear, right? This is I think this is the recent most architectural pattern I've seen, right, in this space.
So हम इसको जो recent वाला architecture है, is there a like standard name for this? मतलब जो हम इसको बोलते हैं, या it's just an improvement?
हाँ, आप वो drop करें. This is called as graph rag.
Okay, ठीक है.
हाँ, this is graph based rag. I think आपको पता ही होगा, right? अभी हम लोग we have discussed enough about that. Now this is a knowledge graph based RAG where you put in all your enterprise knowledge into a graph database. Let's say Neo4j लगा दिया आपने यहाँ पे, right? And फिर आप Neo4j को भी query कर लेते हो और बाकी आप जो conventional RAG कर रहे थे, you do that also. You combine both the results and then give it to that. So you will see that the results are much better in this case. That's what I mean. And there is a use case also where LinkedIn has tried to use this to solve their customer care, customer tickets, customer escalations and all. And
Okay.
this diagram I have taken from their blog itself.
So when you better, कौन सा aspect इसका actually you had touched upon? Basically the accuracy or more
accuracy.
relevance of the result.
Accuracy is better. They have claimed their accuracy to be better.
Okay. ठीक है.
And I think जो answer भी, I think it will be able to more, because LLM को आप ultimately what you are doing is by all of these things, right? You are just giving more context to the LLM, right? Now, if it has more structured data, how that data is represented truly represents your structures inside the organization, right? That much better it will be able to answer those questions.
Okay,
right?
ठीक है. It's more like a pre-processing, मतलब जो LLM को हम दे रहे हैं एक तरीके से, improving on that part. I might be wrong.
Context enriching, you can say. Context enriching.
This is more like giving some kind of proprietary information to it, so that it can. So see, this part is nothing but a natural language processing, right? Because your conventional data stores does not understand user language, right? Does not understand English, right? So that is the reason you need this guy, right? So this guy basically can translate that into this. And by the way, the other aspect to this guy is that LLM is also pre-trained on certain data from outside the world, which is not your data, it could be very generalized data over internet and all, right? So because of these things, it's likely to not give you a grounded result. So what you are doing is you are giving as much as context as possible based on your proprietary data and then feeding it, so that now it can use its natural language capability and articulate it, translate it better in a way that question has been asked, right? In that format, it can articulate it and then give as a response, right? So this is the new pattern. अब एक question I think which all of you should have asked is that अभी हमने vector database में तो it was pretty easy, right? Vector database में हम क्या कर रहे थे? हम जो user का question था उसको हम again एक vector बना ले रहे थे, right? And then this guy was able to do a nearest neighbor lookup using cosine similarity, right? So that is the reason it was able to fetch the documents and then that could be fed. But how do I graph? कोई भी मैं Neo4j अगर use कर रहा हूँ, right? Any graph database, then this needs some kind of, let's say, SQLite structure or some kind of structure, right? That how do I create, right? क्योंकि यहाँ तो मेरे पास English एक paragraph user ने मुझे दिया है, right? Now, how do I convert it to that format so that it can answer? For example, I cannot put, let's say, a user query on MySQL, right? It will not understand it. So, आपको कुछ ना कुछ यहाँ पे एक layer चाहिए, which can extract all those entities from the user, right? So it can extract those from the user and then put it onto the desk. क्योंकि यहाँ पे graph query language यहाँ पे चाहिए होगा, right? So that it can retrieve all those information. So that I think there are some things which I just trying to look up. How does it do is, so there is something called as named entity recognition. So in this, what it does let's say कोई question होगा, so it will try to first parse the noun from that. I think. So to me, it looked like you can just maybe try to create this in like say plain English, that there was a user question. Now you extract what is a noun in that, and then you try to extract what is a verb in that. So noun is nothing but that entity in your system, and verb would be the relationship between those entities. And then let's try to look for some kind of entity ID also in that user input, right? So that entity ID is the lookup that you are doing in that entire graph. Where do you start your processing from, right? So you go to that node and then you start looking for the relationship, and then you do some kind of a search. If you cannot do very deep, because again latency will go for a toss, and then you are on a user path here, right? So you cannot afford more than, let's say, 100, 200, 300, 400 ms of latency. So you you can put up a cutoff that I'll just only go the node depth, and then whatever data that you get, that data you can take out and then give it to the LLM, right? Or also you can put up a LLM again here, right, at this layer. So यहाँ पे graph को input तो देना है, but इस question को you can use an LLM and you can say that, okay, this is my user question, can you convert it to a GraphQL kind of query, and that GraphQL query you take it and then you give it to this guy, and then it gives you the response. I hope it's making sense, right? ठीक है. Yeah, so I think I'll pause here. अगर कोई nothing questions are there. Yeah. So there is a paper also from LinkedIn on this paper. So this I will just ping it. So this is on their customer response, right? So question आप पूछ रहे थे, Ankit sir, right? So this has reduced our method in customer search time approximately 6 months and reduced the median per user issue resolution time by this almost 30%. And there was one more matrix, yeah. And this is performed above the baseline on these parameters. I think all of these parameters also need to understand. But LLMs, these kind of tools are like, let's say, benchmarked on those. So this was able to, almost 80% was able to improve. I'll just put this here in chat. So I was thinking of, let's say, using some of these things to build something in the organization, right? Something for the company. It can be easily used. These kind of tools can be used to build, let's say, one on-call ticket app, right? Yeah. ठीक है. Any questions, or we'll stop and go to the virtual threads?
So this context thing, right? Like you are doing the vector search in your vector database. So when we pass on a query to LLM, so how much context it does build? Like the whole document, or just the paragraph it finds, like the relevant information to the LLM? Like, is there any way to control that? Like how much context it is building out of it?
In during write time or read time?
Read time, when we are doing a query, right? So during the not on this GRAG, but in a normal RAG. So when we are doing a query, so it is converting my query into a vector, okay, and doing the vector search in my vector DB or in memory vector store, and from there it is creating a context to query the LLM, like passing on the query to the LLM to find a better answer. So how much context it is building, it how it is controlled?
Acha, okay. So okay, I think so. Maybe you're asking about some parameters. मैं समझ गया. So one thing, just I again wanted to clarify it. अगर आपको सर ये clear है तो, right? So what? Let's say this is your query vector, right? This orange is your query vector. I'm just giving an example here. This is not. And then B is your, let's say, chunking जो आपने किया होगा, right? Chunking के time पे ये आपका वो उसका chunking का vector है, right? Document vector है. So now what it is trying to do, there would be, let's say, other C, D, E, F, I, G, H, like that, right? अब वो आपका जो query vector है, again is trying to do a similarity search with all of those, right? If I can take a example where more vectors are there, right?
I understand, my like it will have few of the vectors which will be very close to it, like with some algorithm, right? Which will be like result of that query from the vector database. So
yes, right.
So it will pass. It will then convert those vectors into a text or something.
I think I got it. So आप जो कह रहे हो ना, so for example, पहले तो उसने क्या किया, cosine similarity करने की कोशिश की. Let's say brute force क्या होगा? It will try to do with all the chunks के vectors जो है, right? And then it will say कि let me pick the top 10, for example, जो most similar होंगे, जिसका cosine cos theta जो है वो lowest होगा जिसके साथ, right? वो pull किया and then it will give it to the LLM. So इस layer पे आप पूछ रहे हो कि क्या वो return करता है, right? तो वो रिटर्न जो जब स्टोर किया होगा तो उसने जो चंक था उसका उसने वेक्टर बनाया और उसके बाद उसको स्टोर किया था। तो चंक तो था ही, साथ में उसने पेलोड को भी स्टोर किया है। दैट इज कॉल्ड एज द पेलोड,
रॉ डेटा
raw data, raw data from the PDF. So that raw text data is also stored. Only thing is these vectors help to look up that quickly, right? Based on the knowledge understanding, and then जैसे आप अगर normally वैसे look करते तो how would you done is कि it would try to just find that some word from the user query, and then those words it would have tried to search in the document, right? उसमें word match नहीं होता तो आपको कुछ return ही नहीं करता. But in this case, again, since it is creating a knowledge out of it, right, in the vector space, it's able to match even non-lexical matches, right? That also it will try to find, and then those return. So वो actual में वो जब return करेगा LLM को, there that vector does not make sense at all, right? उस layer. Vector का LLM कुछ नहीं कर सकता. It will be a garbage.
It is just a tool like a index in DB.
हाँ, this is just a DB lookup. हाँ. So you take the
vector तो just वो mathematical representation है ना वहाँ पे, तो obviously उसका कुछ नहीं कर सकता.
वो तो बस दो एम्बेडिंग मॉडल जो आपका रीड के टाइम पे और राइट के टाइम पे, दोज आर सेम एम्बेडिंग मॉडल. दैट्स द रीजन दे आर एबल टू डू अ सर्च ऑन दैट, राइट? बिकॉज आपने जो ये इस टाइम में जो राइट टाइम पे ये क्रिएट किया और रीड टाइम पे आपने एक क्वेरी वेक्टर दिया, तो दोनों सेम एम्बेडिंग मॉडल यूज कर रहे हैं. इसका मतलब वो सेम एम्बेडिंग स्पेस पे है, इसीलिए वो कोसाइन सिमिलरिटी मेक सेंस करता है उस केस में.
Got it.
राइट. बट अल्टीमेटली जो रिटर्न जाएगा वो पेलोड जाएगा उसमें, नॉट दैट.
So RAG will be very expensive also, right? If you keep doing with so many documents and big chunks. I think that's what the question was, Jitin was having. Like the context will be more token consuming.
RAG, so आप यहाँ पे क्या यूज कर रहे हो? Yes, आप embedding generation के लिए something you are using, and then LLM you are using, right? So both of these, yes, if you are using, let's say, an outside hosted model, they will charge you based on the token size,
Yes.
right?
Yes.
That would be definitely be costly. But what you can do is, since LLM वाले के लिए you are not, you don't want to use the entire, जैसे GPT, for example, right? Latest model of GPT. I don't bother about what it's been trained on. I don't want to use that, right? Because I'm trying to use it for a RAG. So my idea is to use it for my knowledge base, company's knowledge base. I just want to use its natural language understanding and articulation capability, and maybe reasoning capability. Right?
Reasoning as well.
So I can just take a trimmed down version of that model, which is, let's say, not a $1 trillion dimension model, but maybe let's say 50 million, 20 billion wala jo model hai, right? Maybe smaller also, right? Where I get the natural language understanding capability, and this model maybe I can host on my on one of my server inside my company itself, right? Open source model.
As a shared service, so that others can also make use of it, or particularly this thing.
Now at this layer, maybe you want to put some GPU, or maybe you can see whether, I don't know whether it scales without a GPU. लेकिन अगर आप user path में put कर रहे हो where there are millions of users, then of course बिना GPU के scale नहीं करेगा. But let's say if you wanted to use let's say only for within a team, right? For understanding on the documentation of that team, right? And providing a query over that, then I think you can use maybe CPU based architecture itself.
And I think primary use case भी RAG का वहीं से आया है. So like companies did not want their document to get exposed, right? So अब और plus let's say अगर हम अपने कंपनी के इंटरनल इंफॉर्मेशन को जानना चाहते हैं and want to keep it inside only, so it's like कि आप अपना मॉडल होस्ट करो and train it with your own data, which is RAG, and get the answers out of it. So yeah, सब लोग आई थिंक कर ही रहे हैं ऐसे इंटरनल उसके लिए, इंटरनल नॉलेज बेस के लिए.
ठीक है सर, आप वर्चुअल थ्रेड्स पे स्टार्ट कर सकते हो. आई एम जस्ट कमिंग इन 2 minutes.
ठीक है, आ जाओ, वेट कर सकते हैं तुम्हारा. आ जाओ 2 मिनट में.
नहीं, आप करो, ऑलमोस्ट स्टार्ट करो.
Okay, let me share my screen.
Kunal, do we want to split the recording? I think that would be beneficial topic.
कर सकते हैं. That's a good point.
Kunal चला गया क्या?
Let him come back. We'll wait for 2 minutes.
हाय सर, मैं एक्चुअली आज बहुत लेट ज्वाइन किया, बट प्रीवियस सेशन में जो मैंने एग्जांपल्स दिखाए थे उनको मैंने गिटहब में पुश कर दिया है. अगर इफ एनीवन इज इंटरेस्टेड टू रन लोकली यू कैन टेक ए पुल एंड रन इट. सो ऑल द वर्किंग कोड आई हैव पुश्ड इन द गिट रेपो.
ओके, लिंक रेपो का बनाऊं?
लिंक वो अपने व्हाट्सएप ग्रुप में मैंने ऐड किया था, मैं फिर से सेंड कर देता हूँ. एंड
ठीक
2-3
है.
टॉपिक जो मैंने कवर नहीं किए थे जैसे इवैल, ह्यूमन इन द लूप, वो उन सब के भी एग्जांपल मैंने उसमें ऐड कर दिए हैं. एंड एजेंट इन द लूप आल्सो भी ऐड किया है.
ओके.
मैं लिंक यहाँ भी एक बार पोस्ट कर देता हूँ. ठीक है.
हेलो.
हाँ कुणाल, ये कह रहे थे कि रिकॉर्डिंग्स को स्प्लिट कर लेते हैं, लाइक वर्चुअल थ्रेड्स का सेपरेट रिकॉर्डिंग कर
Okay.
लेते हैं.
ठीक है, सॉरी. हाँ, मैं स्टॉप कर.
स्टॉप एंड